data that you guys might have about your state of your networks and IT systems. And really what we're talking about today, what I call the art and science of hunting for new threats in your environment. I've been doing this for a long time, won't bore you with reading that. I got a lot of my experience with, first with as a founding member of a CERT that some of you in here might know, since we have a big facility here in Richmond. And then I moved on to work for Mandiant and FireEye, and now I work for Squirrel. So I'm going to talk to you about 3 things today. First thing is, the title of the talk is Visual Hunting with Linked Data. So I want to talk to you a little bit about what linked data is, what it means. And then I'm going to talk to you about why you might want to use it for hunting or in addition to what you might already be doing. And then I'll talk to you about using that linked data to create some visualization so you can derive some insights about the status of your networks. So first of all, what is linked data? Well, if you go to Wikipedia, you'll see this. It's a method of publishing structured data so that it can be interlinked and become more useful through semantic queries, which is technically correct, but it doesn't really address the question, what is linked data? So I have my own definition. It's data with links in it to other data. And those links can be implicit links, explicit links. I'll talk to you about those in a minute. But basically, it's data with links. We also refer to these links as relationships. So if you think of your things that you might, who has a SIM? Raise your hand. Okay. Who has Splunk or something that's not a SIM, but you do something with your logs? Okay. If you think of all that kind of data and look inside it, you have host names, IP addresses, user account names, Windows domains maybe, email addresses, details of possibly files that got transferred or were attached to an email. You have the email message transactions and HTTP transactions. All of these things are entities. Some of them are physical things like people or computers they refer to. Some of them are less physical, like the transactions. An HTTP transaction isn't a thing that you can touch, but it's still in your data. You can think of it as extracting these things out, and then based on the log, you can create the relationships between these, and I'll show you what this means. So remember I said we had these 2 types, implicit and explicit. An implicit link is something that is just inferred from the log files themselves. So here you have, at the top here, you have a snort alert about some successful administrator privilege gain. And then you have on the second one here, it's an SSH, remote logon for root. Now, there are implicit links in here. So you can see, for example, you have the root account was involved in both of these. The same 2 endpoint IP addresses and ports. So right now, you can tell that these 2 events are linked somehow. If you were to take those and put them into what we use a lot for this is we use a graph database where the entities that you find in your logs are nodes, like these big circles here. And the relationships, we draw the relationships as arrows. And we name them. So you'll see we have 2 nodes that are the corresponding endpoints of that communication that we saw. We have this one here, it maybe is a little bit hard to see with the blue background, but it says root, so that's the account. And then the relationships are this node connected to, we call that a connected relationship, and then this connected to this node. This account logged into this node. So that's how we've taken that information and derived and inferred some links. And that's implicit linkage. But some things, like the focus of my talk today actually, are explicit links are actually right there in the data as a field or something. So I'm using, in this talk, I'm using a lot of data from the Bro network platform. Who here has used Bro before? Okay, it's a pretty good amount. So all you guys have used Bro before probably already know this, but every single log entry that Bro creates has a unique identifier for that thing that it's referring to. So for example, at the top here, I have a file transfer log. Like it noticed a file with like an MD5 sum here being transferred. Here I have an email log, so it noticed this email transaction. And the bottom I have a connection log, similar to NetFlow or network session data. And each one of these, you see this has a unique identifier for this connection here. And each one of these also explicitly names the connection that it was associated with. So you have an explicit link between this email transaction and what network connection it occurred over. You have an explicit link between this file transfer, this attachment, to not only this email that it was attached to, but also to the file, the connection it was transferred over. But that's not all, as Bro actually does the same thing for the individual files. So you can see that this file is assigned a unique file ID, which also occurs in this email transaction to show you that this, indeed, these two do go together and they weren't just part of multiple emails that went on the same connection. So here we have explicitly stated exactly how all three of these entities relate to each other just because Bro does that, which is an awesome way to pivot through there. Now, if we start graphing these, just like we graphed the simple graph earlier, we start graphing these, you might start with the transactions. So I have the connection, and then I have the file transfer. And it's a contains relationship. So actually, the connection contains this file transfer somewhere, right? That's not all we can get out of it, though. We have these other entities. So we have, for example, this host was the source host for the connection. We have this host was the destination host for the connection. And we have this file that was contained in this file transfer. Now, there's other entities that you could have pulled out of there. It makes the slide really complicated when I start pulling out the email addresses and everything that were the subject lines and everything that goes with all those transactions. But I think you're starting to get the idea is that now with the explicit linkage, we can actually create this transaction node here, and not just that these things are connected, but they're connected through certain transactions. Now, that may not be always the best way to look at this, to have to always go through the transactions on the graph. So I would also like to introduce you to the concept of what we call transitive closure. It means, for example, if this thing is connected as the source to a connection, and this thing is connected as a destination to a connection, we can also make a direct connection so that you can just see, hey, these two hosts connect, they're in a relationship directly. Similarly, this file transfer, this file that we transferred, it was sent by this guy, and it was received by this guy. So we just made some convenience links that were not directly reflected in the actual fields, but they were implied by those fields. So why in the world do we care about this? Anybody in here doing incident hunting themselves already, or someone in your organization is doing it? A couple hands. I should also say this, I feel like incident hunting has like an 80 or 90% overlap with incident investigations. So if something has already detected it. So everything here that we're talking about for hunting, you can also, a lot of it use for your incident investigations. Why would you want to use linked data for hunting or for incident investigations? Well, this is probably how you're doing it now. This is what the folks that are experienced with Bro probably do a lot. They may send it to a log file somewhere on a on a hard drive or whatever. And this is basically me on my Mac grepping around for those links. So you see, I'm interested here in the MD5 sum of a certain file, and I'm finding out where it occurred in my logs. And now I have the connection ID here that I saw that file, and now I want to see everything that happened over that connection. And it's another grep command, and I have it looks like a connection log and a file transfer log and another email log. If you send this to something like ELSA, or if you are paying for Splunk or something like that, you might have a fancier GUI interface, but you're still basically doing these same operations. I call this row-oriented analysis. Nothing wrong with that, and there's still plenty of great use cases for looking at events row by row. But sometimes it really helps you out if you can get a little bit different view. So here we have two perspectives on the same data. So on this side, again, here's me on my laptop here doing a grep through a bunch of bro logs to try to find information about some suspicious connections. And it basically just becomes a wall of text. It's very difficult, but possible, but very difficult to kind of get the big picture of what's happening just by looking row by row. But here, we've actually created a graph that has basically the same information in it, but tells more of a story. We received a malicious email, which was sent to a certain email address. That email address belongs to an individual user who logs into this computer who happened to be compromised by that malicious email. And they used HTTP to connect to a command and control. And we also saw some non-HTTP net flows out to a data exfiltration point. Now, admittedly, not all of this is connection-oriented. These things pretty much are the connection piece. These things are derived from other log sources. All of it came from Bro, though. Bro logs all those things. So if you look at it row-oriented, you have to say, well, I need to grep through my email file and to find the email and the address it went to. You may need to consult your LDAP directory to find out what user that belongs to. If you're super lucky, you can find which users use which hosts from monitoring your bro logs, because they will try to record usernames whenever they see them. And then you go to the connection logs to find out what the suspicious connections were or anything like that around here. But here, I mean, you can just basically see the picture. So not that row-oriented versus linked data analysis is a competitive process. I actually say use both, but sometimes you will have situations where linked data is the better choice, and sometimes you'll have situations where row-oriented data is a better choice. Now, which one is which? Row-oriented analysis operates, of course, on individual events. And there are a lot of existing tools, some for free, some for pay, pretty much can fit any budget and any need. Splunk, ELSA, you saw me using grep a lot. I'm a big fan of grep and awk and sed and those things for log-oriented analysis. But it gets hard to see the big picture when all you're doing is staring at individual lines, because you can't see the relationships. You can't see, it's hard because they're all in different log files and you have to bounce around through and pivot through. It's possible to pivot through those, but you usually have to do it one step at a time, and it's easy to lose track of where you are or where you have been in your investigation. It's really good, though, for searching. If you just have a string and you want to know if it, like an indicator or a domain name or something, you want to know if it occurs in your logs, certainly row-oriented analysis is probably your best choice. Anytime you want to do counting, some basic statistics, all that, especially, of course, if you want the detailed proof, because the log-oriented or the row-oriented events actually give you the most detail about every single event. So when you've completed your investigation, no matter whether you used row-oriented or linked data analysis, you will almost certainly need to go back to the individual logs to extract them and prove what happened. So just as a little bit of more of an example here, this is what you get if you see a typical SIM or IDS alert as it occurs in your traditional graph. So you just get an IP address, you get the IDS alert, and you get the destination IP address. 2 IP addresses, a source and a dest, and the alert probably would have more detail about what the alert actually was trying to tell you, but not so much here. But when you actually send it into a full graph with all of your other data that you're collecting, you start to see a lot more context about that alert. So here's your alert again, and the same to the source IP address and the destination IP address. But now, if you've collected this data over a certain amount of time, you may find, hey, I found this source IP address is associated with a login session around that same time window from this user. So now you can make path. I call this auto pivot plus plus. It's similar to the same way you could use a row-oriented techniques to say, well, find me the IP address, who logged on around that time, who was it? But now we can just basically use a graph algorithm, and there's decades of computer science research about graph algorithms, to say, find me the shortest path in the same time window from this IDS alert to any user account, ask the graph to do all the hard work for you. There it is. That's your user that is probably the one that has to do with that IDS alert. Any IDS analysts in this room ever have any problems tracking down the users? None of them? Some guy was, yeah, 2 guys back there raised their hand, I think. You could also do other things too. I mean, you can see the same type of thing. You maybe find the host name or something. On the destination side, well, here's the IP address and the host name here, but also you may find other HTTP transactions or other network transactions that are also associated with this malicious destination. The URIs, the files, the user agents, or anything that you saw on there. So right then, there's actually a fairly straightforward algorithm for taking your IDS alert or your SIM alert, putting it into the graph, and then extracting the first couple of hops of data and creating a package of context. And that you can just give to your IDS analyst, ideally all automated, but maybe not always. So let's talk a little bit now about how we can use this idea of linked data and linked data analysis to derive some insights for visualization. I do a lot of thinking about how to proactively find threats in your environment that haven't been caught by your automated intrusion detection or SIM systems. And one of the things that I always say is that before you can really start going into the details of individual events that happen, you really need to make sure that you're familiar with the environment and also the data sets that you have. It's no sense trying to hunt down a very specific type of scenario if you don't really know what kind of data you have, what kind of systems that you have, in our case, what the kinds of nodes and relationships in them are. So I always say to start at the high level. Maybe you don't have to do this every day that you sit down, because after a while you start to know the data sets and the organizational environment. But when you're first getting started, start at the high level. So I'm about to talk to you about a bunch of stuff that I've put together to kind of help me. Of course, Squirrel does this thing, does this kind of analysis. We have a commercial product, but that commercial product does not appear in this presentation. I was telling a friend of mine earlier, I created this kind of open source stack because it gives me the visibility into all of the layers. So I can get my hands in it and do prototyping. But I realized it's also a really great idea for people who are interested in just trying out linked data analysis to kind of show this stack. So that this is something that you can go back to your office next week or something and download this software, install it, and start sending it bro logs. I use bro logs a lot because I really like bro. And just kind of try out some of these linked data analysis techniques, these graph techniques, visualization, or if you're really super into computer science, you can try some of the graph algorithms against your graph database. This is meant to be super simple. It's not really going to scale to a big data set. It's something that was designed for me to use with medium or smallish data sets on my laptop to try out some of my ideas. You'll need the following things. First of all, and I'm also almost ashamed to admit it, my test data is from the DARPA 99 set. So it's like 16 years old PCAP by now. There's a side note, but there's a really big problem in the security analytics industry in getting good, realistic test data sets to try things out on. So I'm using this data set for this presentation because everyone in here can access it at this URL and download it. There are certain things in it that people have complained about over the years about how it is not necessarily an awesome data set, but what I like about it is it tries hard to be a realistic data set of a small number of hosts doing real things with the internet. So you will need that. That comes as a PCAP, a packet capture file. So you will also need, of course, the Bro platform so that you can translate that packet capture data into logs that you will then ingest by these scripts here that I wrote in the middle. This is my only contribution to the open source piece, is these Bro to graph scripts, which you will be able to get from GitHub. They're actually not available quite yet because I didn't finish the documentation, but they will be finished and available sometime within the next week. If you follow me on Twitter, I will tweet when those are available, so you'll know. And once you've created the graphs, once you've created the logs and you've got the scripts, the scripts have to take that data and put it into a graph database somewhere. So I'm using this other open source tool called Rexter. There's a interesting graph database project called Tinkerpop, where they tried to be a abstraction layer between a bunch of different types of commercial graph databases with a consistent API and everything. You don't actually need to provide your own graph database, though, because they actually provide a simple one embedded into their solution. So the Rexter graph database. I wrote my code in Python, so I also needed an API. The bulb flow, or just bulbs for Python, you can get that from their domain, or if you already have Python installed, you can just do pip install bulbs. And finally, for the visual layer, all the graphs that you're about to see were generated by this awesome open source graph project called Gephi. There's a note here about a couple of plugins for Gephi that you will need to download and install through the tool. It has its own plugin manager. So here's our first try. I just ran the DARPA 99 data set, loaded the things into the graph database, and visualized everything. I will admit, maybe not super useful, but the nodes are color-coded by type. So you can kind of start to see things. So it's hard to see on this particular one, but there are a few places where there's little dots of red, which are individual hosts. You'll also see like these big green DNS transactions and these yellow file transfers and these blue HTTP transactions and things like that. You can start to see a little bit of information, Like there's this big kind of dandelion-looking feature up here that you might be like, oh, I want to maybe check that out a little bit. There's some semi-disconnected pieces that might be interested to look at. And then you can see a little bit of structure. You can start seeing some structure down here, but it gets really messy. So the problem is I just graphed everything that I knew, which might be okay if you're just looking at general shapes. If you do this for all your PCAP you capture each day, and you do this over a course of a week or a month, you might start to see common features that you know are fine because you see them every day, and then you start seeing giant mutations of the graph one day that might give you a little bit of information about what's going on. But honestly, I don't really derive a lot of information from this. But it turns out that some basic simple things give you some really interesting results. So one of the things I try is to just take all the types of nodes that I have and graph like 2 or 3 of them in relation to each other and see what that shows. So for example, here's just all my hosts. You can kind of see some interesting things, like the thing that jumps out at me is you have these 2 giant dots and this really thick line. So the graph algorithm kind of weights things. Larger dots mean that they have more connections. Thicker lines means that that same relationship occurred more. So here we have like a bunch of small dots that we've probably only seen once or twice, a bunch of thin lines. But when we see this giant set here, that means that whatever that is occurs a lot, and we'll get into that in pretty much detail here. But you can also kind of see things like there's a bunch of these, they look like flowers or maybe, I don't know, bouquets of flowers or something that come from individual hosts. So here's like, these are all the internet hosts that this guy really talks to a lot. And you can kind of see kind of a giant mess in the middle. It's hard to see really what you're talking about here because all of the hosts are colored the same because they are all hosts. So one thing I will do what we call partitioning the graph by color. Now it starts to bring out the hosts that are in green are what Bro considers my local hosts. When you run Bro, you tell it which your local domains are, your local IP ranges are, and it records it when it sees it in the connection logs, or sometimes in the, I think it's the file transfer log. If it says this source of this is a local host, I record that in the graph as they call it a feature, but it's a property of the node. And so I can look and see, and there's 3 categories of things. It's things that I definitely know are local because Bro told me. Things that I definitely know are not local because, again, Bro told me. And the third is Bro didn't say anything at all about this, so I don't know. Usually that's because the hosts occurred in a log file that, but it never saw a connection to it, or it never saw a file transfer to it. I think those are the only 2 places I know of in Bro where it actually tells you local or not with definition. So you'll see the red things are internet hosts, definitely not local. And the gray things are things that I don't really know, but in practice, most of those are also not local. And you start to see interesting things here. A little bit more about this pattern. It's an internal host making a lot of connections to this internet hosts. If it's me, that's probably the one I'm interested in checking out first. So here I'm seeing the same kind of graph, but instead of just doing the hosts, I've added in the file transfers in yellow. And if you look close, you can see that I got the same green and red hosts up here. But now they have that's where that dandelion structure came in, because it was all generated by both of those 2 hosts. Now, there's a whole bunch of other stuff down in here, which is still kind of an undifferentiated mess for now, but we'll see what we can do about that in just a bit. My first question as a hunter might be, well, what are those 2 files? Or what are those files that are around those 2 hosts? So what I just did was zoom into the graph. The graph, once you get a little bit into it so that it can actually tell you something, will tell you the types of hosts. I know it's really hard to read on here, but I wanted to show you that there's still, I mean, even at this zoom, there's just a ton of hosts and everything. Each one of these is a MIME type. And you read that, and you'll see it's image/JPEG, image/GIF, text/HTML, image/JPEG, image/JPEG, etc. So actually, all of those things are HTML pages and images that you would typically expect to find embedded in HTML pages. Remember, this is all 1999, so you're not going to see a lot of Flash or PHPs or anything like that. You're pretty much still talking about mostly static web content at that time. So it's probably all web traffic. Now, that really thick edge, the connected to edge that we saw, was showing that the internal host made a lot of requests to the external host. And then it's all going out. And then you can't see it on here, but the arrows on these are all going the opposite way. So that's showing not that the internal is sending a lot of data out, it's actually sending a lot of requests, but fetching a lot of data, which is pretty normal for HTTP requests. So right there, that's good. It turns out, at this point, I actually found it a little bit easier to go back to the row-oriented thing and just find a couple of these file transfers and see what they were, a couple of these connections. And it actually all turns out to be going to Canon. You know, they make printers and copiers and things like that. So that was actually some Canon device that was calling home. So no problem. All those are HTTP things that we kind of expect. So let's see what happens when we take those things out. They're just junking up my graph, making it really complicated. So let's filter out all of the HTTP and image files. And now you can see we have a little bit more simple graph, right? We don't really have time to go into every single one of those, but I will just say if it was me, I might be interested in going into a little bit more detail about some of these file types here in the yellow. It turns out if you do that, you'll find like a bunch of C source code that they're FTPing around. There's a couple executables that get uploaded to my internal web servers. There's interesting things in this data set that you can find. But pretty much this is how I approach it. I find one thing that I think is interesting, dig down into it, and if it doesn't show me any confirmed malicious activity, then I start thinking, well, let's filter this out and go back through the process again. What's the next thing I want to find? Dig into that. And after you do that for a while, most of them will be nothing, but then you start to kind of, I think of it as distilling. You're kind of distilling the data set to bring the bad things up. So after a few iterations, hopefully you will find some things that are suspicious. That's only, one time that I can say that hopefully you'll find some bad things in your network. No. People get upset at me. I'm like, yes, I found some hacker. My bosses are like, what? No, come on. That's not good. I'll give you a bonus. So we talked about plotting files and hosts together, but those are not the only kind of things that you can plot together. All of the different types of things, it's really interesting to try to plot them together, see if there's any correlations. So here's one where I just looked at the individual HTTP transactions here in green. And then there's some brown nodes right in the center of all these. They don't show up too well on the projector. And they are specific user agent strings that we saw. So user agents for HTTP are how the browsers or the web clients identify themselves. And sure, they can lie. But it turns out a lot of times, just like most people are poor liars, so is most malware. And so just looking at the unique user agent strings in your environment can often give you a kind of a clue about which ones might be a little bit suspicious. So if you think that most of your people in your company probably have the same or similar desktop software loadout, you would expect to see things like giant blooms here and here, which would probably mean most of your HTTP traffic, and therefore most of your users, are using the same set of user agents, so that's fine. When you start seeing a few things here that are less popular, and there's even, if you download these slides and see, there's some really light ones around here, those might be the ones that you want to dig into a little bit and find out what those user agents are. Maybe you will expand the graph then to add hosts to see how many hosts are using those. If it's a lot, maybe it's okay. If it's only one or two, maybe you have something to worry about. So I'm starting to get the time signs. So let me go ahead and wrap up. I'll leave my contact information up here. I will say this is only the tip of the iceberg. I spent a lot of time, if you notice at the beginning of the presentation, talking about how great linked data is in graphs, and I alluded a few times to the fact that there's decades of computer science research on how to derive interesting data from graphs. But I didn't really go into that. There's a couple reasons. One is it just takes a long time, and you could spend a couple of days probably just talking about how cool graphs are when you're trying to do incident detection or incident hunting. The other thing is, though, there are not a lot of open source tools yet that allow you to apply graph technology to security data. I won't say that there aren't any, but the ones that I'm aware of don't really have a lot of complicated graph analytic in them, so I didn't want to start digging into that quite so much. As I said before, I think the most reasonable place to start when you're just getting into linked data analysis is at the top level, visualizations, interacting. If you go to download some of these tools that I mentioned in the earlier slide and try this in your office, either with the DARPA set or your own set, you'll find that Gephi actually has a lot of those graph algorithms in it. It might be a little bit tricky to know what they're for and when you should use them, but it does actually have a rich set. So hopefully if you catch my presentation in maybe another 6 months or whatever, I will have a little bit more detailed information as I put some more into my Broad to Graph suite, put some more of those smarts in there. It can already do a few things like pathfinding. Not super well, but it does them. So you can do that auto pivot plus kind of thing that I talked about, just not visually yet. So I understand I have about, 10 minutes or something like that. So I'm happy to take some questions if there are any.